Hello and welcome to Tech for Non-Techies, the only podcast that demystifies the fast-growing technology sector. I'm your host, Sophia Matvieva, Chicago-based MBA and tech entrepreneur. My aim here is to give you the skills, knowledge and confidence to find opportunities in the tech sector, whether that's through founding a company, getting a dream job, or bringing a fresh perspective to your work. Hello, non-techies. Today, I want to cover with you the concept of algorithms. I think algorithms is this word that we hear a lot, and a lot of people don't actually know what it is. And it's this long, complicated word, and then we assume that it's something very, very complicated and we shouldn't get involved with it. And then we don't even bother asking questions because we don't want to seem stupid. So I want to dispel all of that for you because it's actually not that difficult. So let's get started. We're going to cover what an algorithm is today, how it gets made, and we're going to cover some of the dangers of algorithms and the mistakes that big tech firms have made when they've made algorithms. But firstly, why is it important? Why am I covering this with you today? We often hear that data is the new oil, and venture capitalists and the Financial Times are always writing about how important data is. But why is it important? Why does it actually matter? So, if we understand how our data is being used and how it's being sold, then we will be able to make better decisions about the kind of products that we're making, but also about how we use the products that we're using every day. So your data is already being bought and sold and traded on the open market. You just don't necessarily know about it. So the more you understand this, the more you're going to understand the modern world, the modern business world, and the modern technology world. So whether or not you're going to found a company, or whether or not you're going to make investments or do digital innovation, or maybe you're not going to do any of these things, even if you're not going to do any of these things, I think it's actually important to understand how this stuff gets made, so then you can question whether you want to use it, when you want to use it, and how you want to use it. Because I think these issues are now becoming political issues, societal issues, and not only business issues. With that in mind, what is an algorithm? So I've got a definition here. Software algorithms are well-defined procedures that computers use to solve problems. So what is that in human language? Well, it basically just means that an algorithm is just a set of instructions. So it could be something like, for example, I live around the corner from a subway station in London. So if I was to give instructions to my friend about how to get to my place from the subway, which is called the Tube here, I would say, cross the road, take a left, take a right. Okay, that is an algorithm. An algorithm is a set of instructions. When we're thinking about computer algorithms, so these are computer instructions, there are several rules that we need to adhere to. Basically, these rules form from the fact that computers are stupid. You are a human. You're not stupid. Computers are stupid. Computers only understand very, very simple instructions. Whereas you, a human, you can understand nuance. You cannot give computers nuance because then you will get nonsense. They don't get nuance. So, algorithms have to be simple at their core, and the instructions that you give these algorithms have to be precise. Algorithms are reducible to 3 logical operations: and, or, not. So let's have a really simple example of this. If your website or your app can display its screens in 2 different sets of colors, so maybe in black and in white, and when your customer is first being onboarded, so when they first download or log on to the thing that you've created, you might ask them, which color scheme would you like to go with? The black color scheme or the white color scheme? If your customer chooses the black color scheme, you will then tell the algorithm not to show them the white color scheme. So basically, that's just an instruction. if this, not that. So another thing that is central to your understanding of algorithms is that once you have this set of instructions, then you need to put data in there, which by definition means that algorithms are using stuff from the past. So data by definition is historical. Data is information on what has already happened. So you are taking data on what has already happened and you're putting it into a set of instructions. So if you are creating a startup and you don't yet have any data, then hiring a data scientist or a machine learning engineer is not going to be your first port of call. It's important for startup founders to understand how their data might be used, how they might use or sell or package that data in future. Investors, in my experience, quite like hearing about this. But in reality, unless you have a lot of data, you're not going to need a data scientist. And data scientists are pretty expensive and smart people. So you don't want to have those people just sitting around if you don't have the data for them to work with. And when we're thinking about data, in general, we're thinking about demographic data and behavioral data. So demographic data would be gender, age, where this person lives. Behavior data would be how does this person behave on your app or on your website. So what is their purchasing behavior like if this is e-commerce? Or if you're a content platform, it will be something like how do they engage with your content? What do they read? What do they watch? When do they do it? So generally, when you have behavioral data and demographic data, and you have lots and lots and lots and lots of it, then you can work with data scientists to make inferences about different types of customers and different types of behavior. But you don't need data scientists and you don't need machine learning experts until you have lots and lots of data. So continuing with our algorithm conversation. So what we have established so far is that algorithms are very simple at their core. So they're just a set of instructions, and the data that we put into them is by definition historic. So how do we then use it? We use that data to make algorithms to create a better service. And the idea is that if we have a better service, more people like to use us. And the great thing about having this kind of AI factory, which is based on data and algorithms, is that it's much cheaper than having lots and lots of people create better service. So, for example, Ant Financial, which is a financial services company in China, it serves 10 times as many people as the largest US banks, but at 10 times lower the cost. So that's basically 10 times more service, 10 times lower cost. That is a good thing. If you run a business, that's the kind of business metric you like. If you're an investor, that's the kind of business metric you like. So this is why it's important for investors, non-technical people, for us to understand how this AI factory thing works. So the idea is that we have algorithms that create a better service, which enable us to reach more people at a lower price point. Theoretically, that's a really good thing. So let's have an example of when it works well and when it doesn't. The Netflix algorithm. Netflix works out what we like and what we're likely to like from what we watch, so from what you as an individual watch, but also from what people who display similar characteristics to you, what they like to watch. And I admit sometimes Netflix doesn't get it right, but a lot of the times they do. So what does that mean? It means that when you open up Netflix, it will show you new content that it believes you are going to be interested in. Because a lot of the time Netflix gets it right and you are indeed interested in that content, that means you end up watching the content and, that's when you end up getting into a Netflix hole and, you just meant to sit down for half an hour, but 4 hours and 2 pizzas later, there you are. Or maybe that just happens to me. Anyway, so that's what good data, good algorithms lead to. In Netflix, it leads to better service, which basically leads to more usage. That's your Netflix hole. Let's look at their competitor, which is Amazon Prime Video. Amazon Prime Video, I don't even know if they actually have an algorithm which personalizes the content to you, because for some reason, the kind of content that's being served to me is completely and utterly irrelevant. So there are a lot of shows about cars, and I don't have a driving license. And there are a lot of shows about football, which I detest with a passion. So I don't know, maybe Amazon is just trying to annoy me on purpose, but more likely they just don't have a personalized algorithm which does not collect data on how I like to use Amazon Prime Video, and therefore does not serve me the content that I would like to watch. So while I have sometimes watched Amazon Prime Video, it is not where I go to open the screen and then just see what kind of content is going to be served to me. It's not a place where I do discovery, because their discovery algorithm is rubbish for content. The Netflix discovery algorithm is generally pretty good. So it means that Netflix is providing a better service, Amazon Prime is not. As a result, I am using Netflix to watch more content than Amazon Prime, even if Amazon Prime might actually have the same content. It's just I don't know about it, and I can't be bothered to find out because there is an easier way of doing so on a competitor. And so that means that I'm using Netflix more, which means that Netflix is getting more and more data about my usage and putting that into even better algorithms, which basically increases the danger of me falling into more and more Netflix holes and binge watching series as I lie there covered in pizza crumbs. So these are good examples, but there are also bad examples, and as non-technical people, this is something that we really need to be aware of, because this is where we can really participate. So we've talked a lot about the importance of putting in data into the algorithm. Without data, you don't really have an algorithm. That's not really going to be possible. But what if the data that you're putting in is a bunch of rubbish? So there is a technical phrase that I'm going to use here, and it is garbage in, garbage out. Seriously, developers actually use this phrase, but it's just worth remembering. It basically means that if the data that you're putting in has issues, that means the algorithm is just going to take those issues and is going to make those issues bigger. So algorithms generally tend to amplify whatever it is that you put into it. So if you put in good stuff, you get good stuff at scale. If you put in bad stuff, you get bad stuff at scale. I'm going to give you an example. So there was an images study in 2017 in which images of cooking were over 33% more likely to involve women than men. So literally, images of cooking were about a third more likely to have a woman in the image than a man in the image. So this is a third. Then algorithms were trained on this slightly skewed data set. Actually, what am I talking about? It's not slightly skewed, it's a third. Algorithms were trained on this highly skewed data set. So that's garbage in. Let's see what happens next. The algorithms that were trained on this dataset connected pictures of kitchens with women 68% of the time. So what does that mean in practice? It means that according to the algorithm, if you are a human of either gender, if the algorithm identifies a human standing in a kitchen, the algorithm is going to be 2/3 likely to believe that that human is a woman rather than a man, because standing in a kitchen is a better indicator of being a woman than the female physique. And actually there were examples in this algorithm. The algorithm in the study labeled a balding, portly man standing in front of a stove as a woman, because according to the algorithm, standing next to a stove is a better indicator of being female than an obviously male physique. Now, aside from the fact that this is ridiculous, this is a huge waste of money for the company that created this algorithm, because nobody's going to want to use it. Can you then go and sell this algorithm? Can you then sell this software as a service product to anybody? No, because it's a bunch of rubbish. So this is why it's so important for non-technical people to question what goes into the data, because if your original data set is skewed, your results are going to amplify that problem. So if instead of having a skewed data set, we had 50-50 gender split in the data set, the results of the algorithm would have been different. Another example is a hiring algorithm that Amazon developed. And if you want to look this up, there's a lot in the news about it. It was quite a scandal a couple of years ago. So Amazon needs to hire lots and lots of developers. Amazon is a tech company. They are truly, truly innovative. But this time they really messed up. So they needed to hire people. And for those of you who know how hard hiring is, they were just trying to make it cheaper and easier. So they did what a tech company would do. They developed an algorithm. And the way they did it was they took the past resumes of successful applicants, so that's past data, they put it into a machine learning algorithm, and they basically asked this machine learning algorithm to spot the similarities between all of these successful candidates and then search resume submissions for those similarities. So here we have past data, which is past resumes, and then literally the instruction is look at the past data, find what's similar in there, and then look at incoming resumes and chuck out anybody who doesn't have those characteristics that the successful applicants do. So what do you think happened? Now, most of the people who are working in computer science roles in Amazon happen to be white men. So that is a unifying characteristic. So this algorithm spotted this and then decided that the winning characteristic of a great software engineer that does well at Amazon is that they are a white man. So any resume that came in that was not from a white man was immediately thrown out by this algorithm. So even if you are a PhD in computer science from Harvard, but you happen to not be a white man, essentially what this algorithm would have done is it would have sent you an automated bot response saying, thanks for your application, but no thanks. So this is a disaster in so many levels. Obviously, it's a societal disaster, but this is not a social justice podcast, so we're just going to talk about the business aspect. It's a disaster for Amazon in various ways. One, it's a PR disaster because if I'm telling you about it, then clearly it's not a secret. But also, it's a disaster for the company in terms of its actual hiring. What they wanted to get was an algorithm that is going to help them to find the best people. That's not what it was doing. And moreover, not only did they not find the best people for the job, they also really pissed off the people that applied and got rejected with a bot. Because imagine if you are this computer science PhD from Harvard and you've got all of the credentials and more, and you apply to Amazon and the application took you a while. We all know job applications, especially if you do them well, it's going to take you a while to do. And then all you get is a bot response. How are you going to think about that company? Are you going to necessarily be that interested in working for them again? No, you're going to go somewhere else. So actually, they completely shot themselves in the foot there. And that's because they literally didn't have anybody to say, well, what kind of biases do we have in the data? And the thing is, we live in a biased world. We don't live in an equal world. We have racism, we have sexism, we have, in the UK, we definitely have a class system. So there is all sorts of stuff that if you're just looking into past data and you're just putting it into algorithms as it is, you're going to have fat, bald men labeled as women because they're standing next to stoves, and you're going to have people who are not white men being rejected from jobs, even if they have all the perfect credentials. So this is not a world that we want to live in, but also apart from the societal aspects, again, this is not a social justice podcast. There are lots and lots of those. This is about business. If this is the kind of algorithms that your company is creating, then it's going to be creating a rubbish service, which basically means that it's going to be amplifying rubbish data, amplifying a rubbish service, and making your company and your bottom line worse off. So, as non-technical people, if you understand the basics of how the instructions of the algorithms are made and what data goes into them, you can just ask logical questions. Is it skewed? What kind of past practices did we have? Is it segregated by gender? Is it segregated by race? Is it segregated maybe by private school education versus public school education? And these are questions that non-technical professionals are perfectly capable of asking. And if you're asking the right questions, you will be able to create better algorithms, but also a more equal and pleasant society to live in. If you want to learn more about AI, then we've got somebody who knows far more about it than I do coming up in the next couple of weeks. We're going to have a live session with Marco Ianciti. Marco is a professor at Harvard Business School where he teaches digital innovation and he teaches about artificial intelligence. So he's a Harvard Business School professor. I am not. He knows much more about this stuff than I do. And he's also an author of a book that I have recommended to lots and lots of people called Competing in the Age of AI. And I'm going to put that in the show notes. I highly recommend that you get it. Non-technical people can totally understand the content in it. Join us for the live session. I'm also going to put a link to that in the show notes. If you can't, the recordings are going to be available in full in the Tech for Non-Techies membership. So if you're not yet a member, I would have a think about that. On that note, I'm going to sign off and wish you a wonderful day. And if you liked this podcast, then I would be really super grateful if you could rate and review, because it's going to help me, but it's also going to help people like you to discover this content. And that would just be super wonderful. Thanks for listening. Have a great day.